India Orbital Data Centre Satellite latest news. PCS, a Bengaluru-based satellite imaging company, has partnered with Sarvam to launch India's first orbital data center satellite, named Pathfinder. Scheduled for launch in late 2026, the 200 kg class satellite will combine data center-grade graphics processing units, GPUs, with PCS's hyperspectral imaging technology, enabling advanced space-based data processing and AI applications. About Orbital Data Center. An orbital data center is a network or constellation of satellites equipped with powerful graphics processing units, GPUs, similar to those used in terrestrial data centers. Unlike traditional satellites that mainly transmit data back to Earth, orbital data centers can process data and run artificial intelligence models directly in space. The concept extends the idea of edge computing, where computation happens close to the source of data generation instead of relying entirely on centralized cloud systems. In space, this allows faster and more efficient data analysis on board satellites. Pathfinder as a demonstration mission. PCS's Pathfinder is being developed as a single satellite demonstrator to test whether data center-grade hardware can operate reliably in the harsh conditions of low Earth orbit. The project aims to evaluate the performance of advanced computing systems in space, especially under extreme heat and radiation conditions encountered in orbit. Why global firms are interested in orbital data centers. Rising pressure on Earth-based data centers. Growing demand from artificial intelligence has increased pressure on terrestrial data centers, which face constraints related to energy, land, water availability, and regulatory requirements. Advantage of continuous solar power. In space, satellites can access near-continuous solar energy, offering a potentially abundant and uninterrupted power source. Supporters see this as a major advantage for running energy-intensive computing systems in orbit. Reducing data transmission burden. Earth observation satellites generate massive volumes of image and sensor data. Processing this information directly in orbit and transmitting only the final results can significantly reduce data transfer costs and communication bottlenecks. Strategic competition among tech companies. Major global technology and space firms are increasingly exploring orbital computing as a future strategic sector. Elon Musk has suggested that advanced satellites and reusable rockets could support large-scale orbital computing infrastructure in the coming years. Companies such as SpaceX, Blue Origin, Microsoft through Azure Space, and Lone Star Data Holdings have already initiated pilot projects, although commercial-scale orbital data centers are yet to be achieved. Challenges facing orbital data centers. Heat management in space. Although space is extremely cold, its vacuum prevents convection, the natural process through which heat is carried away on Earth. As a result, powerful GPU chips used in orbital data centers can overheat easily. Radiative cooling systems. To manage heat, satellites must use specialized cooling systems that circulate heat through ammonia-filled loops to external panels, which then radiate the heat into space as infrared energy. Radiation damage. Cosmic radiation poses another major challenge. High-energy particles can cause bit flips, where computer data changes unexpectedly, and can gradually damage semiconductor components over time. Limitations of space-grade hardware. Radiation-hardened chips used in spacecraft are generally less advanced than commercial GPUs on Earth, creating performance limitations for space-based computing systems. Power storage constraints. Orbital systems rely heavily on solar energy, but they must also store sufficient power for periods when satellites pass through Earth's shadow and sunlight is unavailable. Maintenance difficulties. Repair and maintenance in orbit are extremely difficult without robotic servicing systems. Therefore, Orbital data centers must be built with strong redundancy and backup mechanisms from the beginning to ensure reliability. PCS, Sorbum Partnership for the Pathfinder mission. PCS will design, build, launch, and operate the Pathfinder mission, while Sorbum will provide the artificial intelligence infrastructure and language models. The satellite will use onboard GPUs to run AI models for both training and inference directly in space, reducing dependence on Earth-based data centers. PCS's hyperspectral imaging camera will also be installed on the satellite. This will allow images captured in orbit to be processed in orbit itself, with only analyzed results transmitted back to Earth. Can space-based data centers become cheaper than ground systems? At present, operating data processing infrastructure in space is more expensive than running similar hardware on Earth. According to PCS, a single satellite carrying GPUs costs significantly more than a comparable terrestrial setup. Supporters of orbital data centers believe costs could eventually decline due to deployment of large satellite constellations, reduced launch costs through reusable rockets like Starship, and lower long-term expenses related to cooling and electricity in orbit. Independent studies and space agencies remain more cautious. While limited edge computing in orbit is considered feasible in the near term, replacing conventional cloud infrastructure is widely viewed as a much longer-term possibility, potentially requiring 10 to 30 years.
Thank you for watching. Helps you in your UPSC journey. Don't forget to subscribe to our channel for more guidance and click the bell icon to never miss an update. Keep studying hard and good luck.